right, welcome. It's so great to be here. Very excited. There's a few interesting things I would like to tell you about today. Who heard the name vlayer before, by the way? Right? Nice. For the video reference, half of the people. So yeah, today is a very special day, and for me, because I'm gonna lift a little bit of veil of secrecy what we're doing at vlayer. We've been talking a little bit about general thing that we're building, but we never showed publicly kind of the code snippets or how that's all gonna work. So it's gonna be for the first time, and because today we're gonna announce our closed alpha program. So if you like what I'm gonna show you today, you're gonna be able to get access and play with it. All right. So yeah, and it feels perfect, like the last event of the week. The energy is a little bit lower, but it kind of, lets you digest a little bit and kind of prepare mentally for the next intense event that is coming soon. Good. So what we've been talking a lot is we are verifiable data infrastructure. So what does it mean? We want to bring data on-chain from various sources. And the various sources, the main three sources we would like to start with are web proofs, on-chain proofs, and email proofs. You might have heard different names for them. There is quite a mess with the naming. TLS notary, ZK TLS, it's what web proofs are often called. On-chain proof, also storage proofs, email proof, ZK email. So you're probably familiar with at least some subset of those names. But we would like to bring them in a different way that anyone ever tried before. And that starts with a new execution model, new and old. So the new execution model works in the following way. We're bringing all the data straight to Solidity smart contracts. But to ensure reasonable computational capability and to ensure reasonable privacy, we're going to introduce two new types of smart contracts. One we're going to call prover smart contract, and one we're going to call verifier smart contract. So you probably, most of you is probably already thinking that might look kind of familiar to other things in the ZK space. And if you looked at blockchains like Mina or Aleo, that might look even more familiar. Who thinks it looks familiar? All right, so again, roughly a half of the room. So, one more question for reference. How many people write something in Solidity or at least kind of know Solidity good enough to read? Okay, that's even more than half of the room. All right, so that's a prover smart contract. So for vast majority of you already know, this is Solidity. It's a normal smart contract you can compile with your favorite tooling, whether it's Foundry, Hardhat, or whatever else is your favorite one. And the only big difference, there are two big differences versus any other smart contract. First, it's going to inherit from the prover. And second, the first thing that it's going to return is going to be a proof. We don't need to think much about what a proof is now just yet. But it's the only two requirements for the smart contract to be a prover smart contract. And in fact, it doesn't really need to be a prover because that's only for getting some extra functionalities. In theory, we could even skip on that part. And everything else is pretty much like in the smart contract. Well, there's one more little detail here. We have this set block over there. So that's going to actually make that little feature makes it so when we require in the next line, when we're going to ask who the owner of the specific board ape is, this specific query gonna not be related to the current block being mined on the blockchain, but to a historical block 1229922. So yeah, that's a prover contract, and and the most important thing, the prover smart contract is intended to be executed off-chain. So it's not being executed on L1 or L2, but it's executed off-chain on vlayer node. By default, all the inputs are private, not intended to be published on the blockchain, and everything it returns is intended to be public on the blockchain. And no usual gas fees applies as expected. It's going to also have some new superpowers that I'm going to talk about a little bit later. Here is a verifier smart contract. Kind of is like any other smart contract. There are a few differences though. It inherits from verifier. And the reason it inherits from verifier, it has this only verified modifier. And only verified modifier, you might be already guessing what it does. It makes sure that the data passed to the smart contract was verified, which was the result of execution of the prover is verified, right? So the first argument on the only verified is a smart contract, the prover smart contract. So we deploy the prover smart contract on chain, even though we don't intend to execute it on chain, but we need some single source of truth, and it happens that blockchain is pretty nice single source of truth. Now, so the first argument is the address of the contract, and the second is just a function, or what we use in the Solidity, which is function selector. And that's it. We also need to pass the first argument. It always needs to be a proof. So only verified doesn't really, we don't pass proof to only verified, because only verified can get it from message data. But what only verified does is look at all the arguments of the claim and making sure they are a result of the execution of the prover. Right, so just for the reference, we have two arguments, proof and address. And if we go back, you see the two things that were returned by the contract were proof and address, right? So the requirement is prover needs to return exactly what verified takes on the argument. Is it all obvious now? Am I going too slow? Some people are like, yeah. No, okay, good. Yeah. Does that make sense? Yeah. Is that easy? I think it's easy. Hope it's easy. Yeah, so verifier inherits from verifier contract, validates computation by prover with only verified, and executes on-chain. Easy peasy. So today we're gonna talk about 2 out of 3 data sources, specifically about web proofs and email proofs. We're gonna leave the on-chain proofs, which are the most interesting, a little bit later this month. We're gonna reveal more details about that. So web proofs. I think there was a lot of noise about web proofs in recent weeks around Twitter and a few other places. But I think it's really good to, when we're talking about something, to make those tangible use cases. So I prepared 2 use cases for you today. One is real-world assets. So how can we improve real-world assets with storage proofs? Imagine you have a token that you would like to issue that represents a real asset in the real world, whether it's a stable token, gold, some kind of security, US bonds, you name it. Imagine you want to issue such a token. Well, first, an application can require to generate a proof, and when you click generate proof, you jump into the other application. The other application could be like your Revolut account, your bank account, whatever else. And here's a special plugin. The plugin kind of gives you an interface that makes sure you follow the steps to get to the right page. And when you get there, you can click generate proof. And when that happens, you can go back to this application. The proof is generated, and you can issue real-world asset. Obviously, that only solves half of the problem, because it only makes sure you have money on the account when you issue asset. And then the question is, what happens the next day? So, of course, some routine check is required, and we're never going to have fully permissionless real-world assets, but we might make it trust minimized, which is the goal. And a second example that probably a lot of you already heard about is Web 2, Web 3 market. So that was originally innovated on by a great ZK P2P team. And in this example, we're gonna try to, Web 2, Web 3 markets, by the way, that can be a lot of things. ZK P2P specifically work on on-ramping, so exchanging fiat money for tokens, and more recently on domains. But it could be any financial instrument. You could buy shares in the companies. You could trade virtual items in the games. So I think that's one of the huge industries that's gonna happen in the upcoming years. There's a lot of annoying details that needs to be figured out along the way, but it's definitely doable. So in this case, let's say you wanna swap, you wanna buy 200 USDC for 200. Boom, you go to your Revolut account, you do the transfer, you go to the right page, you generate a proof, and someone on the other side sends you tokens back. Good. So there were two examples. I'm gonna kind of show how that would look in the prover. That's gonna be a simpler example than the two I talked before. So that's gonna be just trying to obtain your Twitter name from the web proof. So with vlayer, you can basically do it like this. Just create a function that takes a web proof. Web proof can be obtained by the plugin. And you can verify it against specific address, so you know it came from this specific address and nothing else. And then you can use a special precompile that we're adding to provers, which can parse JSON. Boom, 3 lines of code, and you're done. Yeah, this is how it looks in the. So I skip a lot of little details here. Like there's a lot. The Solidity is full of those little modifier fields, but this is the real example that is working that you can download from our repository. Yeah, and we have the proof here, right? That was missing on the other slide. Yeah, so and web proofs that gives you private attestations of the private web data, JSON precompile, and web browser extension, everything working out of the box in vlayer. Okay, and how do you obtain a web proof? Well, we created a JavaScript API, an SDK, where you say you want to create a web proof, you give a logo of your application, and all the steps, like you need to go to this page first, then make sure that the user navigates to a specific place, and then there is like a notarized steps. Might be a few steps, might be a lot of steps, might be one notarization, might be multiple. So this is actually copy-paste from the same working example. So that's not even like simplified or anything for presentation. And this is how it looked like in real life plugin. And all the different stages kind of go through. Good, so that was web proofs. Now let's move to email proofs. Yeah, so I guess that, again, I will try to make it as tangible as possible. So one common example when it comes to ZK email is wallet email recovery, especially now that account abstraction is getting a lot of traction. That becomes more and more attractive way to interact with wallet. So here's the flow. It's quite simple, but it's tricky to get it right on the first try. But you need to start on the website. When you say, hey, I want to recover my wallet, let's say I'm Elon Musk. This is my new address that I would like to control my wallet. This specific application is sending me an email, and I hit reply. So usually when in the web 2, I would hit on the link, but it's ZK email, so I hit reply, add yes or confirm or whatever, click send. It goes to the server, and the rest happens magically, right? And ZK email has a very strong security guarantees, meaning that we can verify its digital signature of mail providers, and that's something we tend to trust a lot. And I would also like to touch on the real-world asset example, because looking at real-world assets from the web proofs and email proofs really help us emphasize on both differences and similarities of two approaches. So in real-world asset example, we would need to start in admin panel on some kind of application, and that would, on our, let's say, real assets admin panel, and we would need to go to our mail client, find the right mail, and using the plugin, we could generate a proof, right? So those two cases are very asymmetrical because one, I'm just sending an email and that's really easy. The other one is installing plugin. But by the way, in Web3, we're really good in installing plugins on user browsers. So yeah, boom, we generate a proof and we can submit proof and go with the flow. Yeah, so this is an example code for ZK email. We start with a main function on the prover. It has we can pass the whole unverified email. We can verify email with a single Solidity call, and then we can start querying the email. And I don't think it's on the slide, but there is a regex precompile, so you can parse regular expressions. Yeah, and that's so that's a simplified version. That's a real version in our example. Yeah. So a few things perhaps worth mentioning is we probably want to pass the target wallet and return it as a public output, because otherwise someone can front run our transaction and take our proof and assign it to himself. We of course need to return proof, and we can get a little bit of privacy by submitting a hash of the email instead of the email itself. Right. Yeah. Yeah. So how do you work with vlayer? Well, it's really simple. You download vlayer, you do vlayer app, you install vlayer application, and you do vlayer init, and you can add a template and start with any of those examples we discussed and a few others. And that's gonna do a standard Foundry project where you can compile your smart contracts with Forge, and you can do all the things you do with Forge, but additionally, it's gonna install this vlayer client that allows you to run execution of prover. And we prepared a book, so there is everything, all the examples, all the little details are explained, so this is available. Available now. Yeah, and I talk about a few things we're doing, and a few things you will be able to use with vlayer. I thought it's worth mentioning all the things you don't need to think about or even know about when you're using vlayer. So you don't need to know anything about math and ZK. You don't need to know what prime fields are, or what elliptic curves are, or what the circuits are. That's one thing you don't need to know about. You don't need to learn any new language. If you're already a Web3 project, you probably have someone who already knows Solidity. You probably have an auditor that is already auditing your Solidity. And you already have continuous integration set up, compilation process, you know how to write tests, and all that stuff. When it comes to verifiable computations, you don't need to know what the DKIM records are on email, or you don't need to know who is the notary, or what are multi-party computations. I didn't talk much today about storage proofs, but if you were to use storage proof stuff, it's all in the book, so if you want to get a nice early access, you will be able to see how we do it. You don't need to know what the storage proofs are. You don't need to know what are the different fields in the headers, what are slots on Solidity smart contract, and you don't even need to know what the ABI encoding is, because everything just works out of the box. Yeah, and when you look at a lot of those ZK projects, you're gonna see those architecture diagrams. Here are some examples of architecture diagrams you get to read in the introduction to various different projects. So that's our architecture diagram. Yeah, and it's exclusive offer for the people here today with us up until the video gonna go online, which I just discussed with Gaylord, gonna take a week or two at least.
I said don't put me on that
maybe a little bit longer. So yeah, this is small but important announcement. There's an alpha program, so if you like to be the first to play with it, give us feedback, see if it works or if it's a sham. Just scan the QR code or type the link, fill in the form, and we'll be sending invitation tomorrow and at the beginning of the next week. Yeah, I'm just gonna mention there are other goodies we've been working on very hard. So we've been working on the web proofs report that is now public. It explains if you don't know yet what the web proofs are or have a general idea, or you have friends that have general idea but would like to understand a little bit more, maybe in the product or maybe not so deep in the ZK, then there is a great report that explains it in very detail, but skipping a lot of cryptography jargon. There is an email proofs report coming in a week or two, and on-chain proof or storage proofs just 2 weeks after that. And so feel free to scan this one as well if you would like to get access to that. I'm also gonna mention we have a blog post. So Maciek is here with me here. We have a blog. We have a few white papers written that explains deep cryptography or security assumptions of different approaches to different web proofs. So that's an in-depth analysis that were not done by anyone before us. So we really get deep into all this stuff, and we want to make sure that anyone who wants to be convinced that this stuff is working have all the knowledge required to understand how it all works under the hood. Yeah, and feel free to follow us on Twitter as well and see to get updates on all the things we're gonna publish in upcoming weeks. Thank you.